and AX. Think about a pin. Pretend that this is a body like this, right? It's a pin connection. Pin connections freely rotate. They have no moment resistance. But if I put a force on it like that, it resists X and it resists Y, doesn't it? But it doesn't. All trusses, when we analyze these later on, when we look at analysis of structures, chapter 6 in your textbook, we look at every one of these connection points as pinned. No moment resistance. All right? It has moment resistance, but it can be negligible, which is fine, because if I have a series of those structures and they're interconnected, it's a rigid frame, which is taking care of the moment. So, this here is what they call a rocker or a roller. It has a single reaction perpendicular to the plane. So here I would call it B or BY. 1, 2, 3 unknowns. If we know what the weight of the truss is, and we know what this is, all right, whatever that is. This could be 1,000 newtons for all I care. I don't care. Now, if I know what this is and this is, I can solve for these support reactions with my three equations: sum of the forces of X, sum of the forces of Y, and sum of the moments. Now, the sum of the moment equation, I can use that multiple times. I can keep summing the moment, right? So I can utilize that one over and over again. Sum of the forces of X and Y I can only use once. So for instance, just to solve for one component of this problem, sum of the forces of Y is equal to 0, right? 1,000 newtons plus 24 times 900, 9.81, those are both negative forces, right? Plus the unknown AY is equal to 0. I only have one unknown, I can solve for AY, right? Let's say AY comes up with a negative, like what if I did this? What if I said AY looks like that? And I set up my whole equation, set it equal to 0. I'm gonna get a negative answer, aren't I? The magnitude is going to be correct. The magnitude will be correct, but the negative answer tells us we assume the wrong sense, and we change the sense. Because we may not always know. In fact, I'll tell you right now, the sum of the forces of X is equal to 0. These can't be both pointing the same way. They can't be. Right? One of them's pointing the other way. I can actually tell you which one's pointing which way just from intuition.
Will the bottom one be pointing the other way?
Which one?
The bottom one be pointing the opposite direction?
Would the bottom one be pointing the opposite direction? Is that what you think? Okay. Intuition tells me no, but I'll tell you why.
Oh, interesting.
Yes.
It's the top one, mainly because if B is a rigid point, then the entire weight system is going to be pulling the A outwards, so the opposite action has to be into the wall.
Yes. You started out, I wasn't sure if you were saying it right, but you were right. Yeah. Think about it this way. If I'm pulling hard down on this, it rotates about that pin, right? So it's pushing on this really hard. This has to be pushing back. What happens if I keep pulling until it fails? Which way is it going? It's pulling this way, right? Off of it. So that has to be going that way.
I wasn't thinking of the reaction.
Yeah, I know. But now you will, right? For the rest of your life, you'll think about it that way. And the other thing I'm going to tell you is, it doesn't matter. Put them both this direction.
Well, you'll find out.
If you sum the moments with respect to here, and I find D, based on this moment, that moment, and the sense of the moment, right? And that moment in a sense. When I solve for it, if I get a negative answer, that tells me something's wrong, right? The magnitude could be correct, but the sense is wrong. But in this case, it would be right. I get a positive answer, right? Because this moment is a positive moment with respect to A, right? BY times 1.5. I call it BY. It's BX. We're taping that too, right? Things happen. Yes.
So AY points up because it's like the equal and opposite,
Yes.
equal down.
Yeah. Whatever this is and this is, it's got to be that.
So
Right?
should
To
it-
keep it in a state of equilibrium. If this and this wasn't that, that's coming down. It's moving, right?
Shouldn't AX go left then?
Yes, that's what we were just saying.
Oh, okay.
Yeah, it would. But you can just throw them both in like this. I can solve for BX. Then I do sum of the forces of X is equal to 0. We know the BX has to be equal to AX. And if BX is over, we know it's pointing that way, that one has to point the other way. But yeah, that's the concept behind it. But the beauty is that you don't have to know the senses of these forces. You can simply just throw them on it, and when you solve it, assuming you solve it correctly, the magnitude will be correct, and if the sense is just showing a negative answer, you just have to pick the wrong sense, that's all. Make sense?